Hi everyone, my name's Kunal Riker. I'm the CEO here at Datum. Appreciate you all spending the next hour with us as we start to explore the arena of pandas for Excel addicts. Thought I'd just spend a minute giving you a little background on who Datum is for those of you new to our company and our team.
Datum Kunal, put it in full screen.
Okay, let's see. There you go. How's that?
Better.
Perfect. So Datum is an energy-focused data science education and training company. We do the hard work of translating the best of what data science and code has to offer into something useful for us as energy industry professionals. Our MO is to build interdisciplinary training programs that marry geoscience, petroleum engineering, and data science together, and to teach those programs to professionals who want to learn how to implement those workflows and skills themselves. As an example, from the partners we've worked with already, we've probably saved over 10,000 hours with some of the workflows and tools that we teach. A key part of those time savings comes from the Pandas workflow we're about to walk through. And so holistically, we teach and train via a three-pronged approach. Workshops like the one where you're kind of sitting in now, where we introduce data science concepts. Enterprise programs where we help build workflows using your data. And then third, as Avi already mentioned, is our new learning management system, which you'll soon have access to and can register for, where you yourself can engage on kind of a self-paced learning journey. So now a little bit about our team. If I had to summarize it in one word, it would probably be multidisciplinary. So the Datum team is comprised of geoscience, petroleum engineering, software engineering, and finance professionals and expertise. So whether you're interested in something engineering specific, geo-specific, finance, or even HSE specific, our team can help you apply data analytics and science to whatever workflows you're interested in scaling up, automating, or diving deeper into. All you have to do is ask. And so with that quick introduction, we have a lot to cover today, and I'm sure you're itching to learn something new about pandas. I'll hand it off for your lecture this morning, the one and only Dr. John Foster.
Thanks, Kunal. So I'll go ahead and start by sharing my screen. And Avi just showed you the 2.0 version of our learning management system. This is the 1.0 version, if you will. And just scrolling through some of the things we teach, an introduction to energy data science course, subsurface machine learning course. And again, we teach this 2-day micro course, 2 half-day micro course on Pandas for Excel addicts. And that's kind of what we're highlighting today. That course has a formal lecture on Pandas, which will, formally introduce you to it. Pandas is an extension library for the Python programming language that's really good at working at tabular data. You can think of it as a lot of the same operations that you would do in Excel is what you would use Pandas for, but of course we can do a whole lot more, and hopefully I'll give you an idea of some of that. So the 2-day micro course has formal lectures followed by exercises that we work through and ensure that we're kind of building up to this more complicated workflow. And today we're just going to jump right in and work through this workflow, because I think that is the best way to kind of give you an overview of all of the capabilities of Pandas, or I mean, of course, not all of them, but many of the capabilities of Pandas in a workflow setting that would allow you to reproduce things that you might commonly do in Excel. And of course, hopefully I'll show you a few things that will take it even a little bit further. So this is where we'll start. We're going to work in this Jupyter Notebook environment in the Python programming language, and I'll be doing some live coding here. In the interest of time, I'll also be copying and pasting code from another document I have, just to save time for me having to type everything out. I'll do my best to explain every operation along the way, and we can see that we build up this fairly complicated workflow in the next 45 minutes or so. Before we do that, let me show you what the workflow looks like in Excel itself. So here's an Excel worksheet. that probably every production engineer has something similar on their computer and work with daily. So in the top left-hand corner here is just what we would call price deck information. So, you know, a price of oil and gas, differential pricings, percentage of NGL, taxes, operating expenses, et cetera, right? So these would be different for every well and every day, of course, but these are often what we use to do resource economics to understand the viability of a well, how long we expect it to be profitable, and make decisions based on that. So what the input to this worksheet is, of course, is the price deck information up here on the upper left, and then two type curves. So type curves are just curves that are, if you're not familiar with them, they're just basically projections for the monthly production of oil and gas. We use the information that, you know, if it's a well that's already been in production for some time, we would fit a curve to that production data and project it into the future using certain models. And then from that, we can use the rest of that. The rest of the worksheet here is basically just built up from the price deck information and the type curve here. So percentage estimated ultimate recovery for both oil and gas. And then over here is all the economics. So how much revenue you could expect for oil and gas and NGL. And if you were to click on any one of these cells, you could see the Excel formula up there in the upper right, well, here in this highlighted region. I think most of you are familiar with Excel, so you know where the formulas are. But nevertheless, then you can go on and compute several other things, including kind of, you know, if you just wanted to get the highlight of what's happening with this well, you'd have an internal rate of return of 70%, given these economics, these numbers, and the well that we're looking at here. The return on investment would be 2.89. You'd become cash flow positive in 1 1/3 years, and your NPV10 is $3.5 million. So this is just a summary of what's happening with this well, computed from all of the information here. So what we're going to do in the next 45 minutes or so is try to reproduce this workflow, but then also take it a little further to demonstrate things we can do within Pandas and the Python programming language to get a little more insight out of our data. So returning to our workflow. So that price deck information that was in the upper left-hand corner of the Excel workbook has been replaced here, and this is just a Python dictionary that contains all of the information, the same information. So for example, an oil price of $50 with a differential of $3.81, a gas price of $2.50 with a differential and shrink, NGL price, taxes, ad valorem, severance, et cetera, operating expenses. So all of the same information that we need is sort of inputs to our workflow. So what we'll do here is we're working in a Jupyter Notebook environment. So we're going to execute kind of one cell at a time and add code. Well, the way you load Pandas is always import Pandas as PD. So if you're familiar with Python, you know we always have to import any external packages explicitly into the namespace. And we always want to use this type of import statement, import Pandas as PD. And the reason for that is just idiomatic in the sense that when you go out to the web, when you go to the Pandas documentation, when you go to Stack Overflow to look at help, Pandas is ubiquitously referred to in these namespaces as just simply PD, and you'll see that later. So we always want to, just be consistent so that our code is more readable, and when we go out and look for help, we can also have readable code. So the first thing we're going to do is import from a CSV file. So CSV is just a comma separated value file, our type curve information. So in this example right now, at least, we're going to just assume that the type curve is given, perhaps from a tool like WinProp or some of the more modern tools for computing type curve analysis information. So if we look at what the so-called data frame is, so again, a data frame is the fundamental data structure in Pandas. And it consists of something that kind of looks like an Excel workbook sheet. You have what's over here in the left in these bold letters, that is called the index. And in this case, it's just a monotonically increasing set of integers that happen in this case to correspond to the months of production. So this is oil in barrels, this is gas in MCF from months. And you can see that this starts at 0, which necessarily, if it was truly a month, that wouldn't make sense. You wouldn't start with some oil production at month 0, it would be month 1. But we can actually rename this index or re-index it from 1 if we want. Another thing we can do with the index, which doesn't make sense here, but is more useful in time series data, is the index could be a timestamp itself. And so therefore you'd have some timestamp information. I'm sorry, I'm taking a look at the, so there's a question, did you define the data path beforehand? In this case, this is, I have a folder in this workflow that's at the same level as my workbook here, and the folder is called data. And so this is just Unix syntax to say, go up one directory, open the folder data, and then inside that is type curve1.csv. So if you're working on a Windows machine, you could have the entire file path, something, C:, and you could put the absolute file path to wherever it is on the computer. If it were happen to be in the same exact directory, you don't need any of this. You can just use the file name itself. But in this case, this data is housed in a folder called data. Again, I've just been discussing the data frame here, and across the top are labels. So this is one kind of big difference between Excel and Pandas, is that we actually get to refer to our data by a label that we're allowed to specify, and we'll see more of that later. Whereas in Excel, you have to use the A, B, C, D type labels at the top, which makes your formulas, when you begin to code them up, less readable, in my opinion. And so in this case, because our index actually does refer to months, what we'll go ahead and do is actually rename the index, just again for readability in our code. So we'll go ahead and rename the index to be month, and we'll give it this in place option, which just means change the actual data frame in place in memory, don't make a copy of it. Just save space in memory on my computer. In our longer course, I try to talk about idiomatic coding styles, software engineering concepts like continuous integration and unit testing, memory usage, and in general, just try to make you a better coder, not necessarily just teach the basics of Pandas itself. So there's our data frame, and one nice thing about data frames for exploratory data analysis is they actually allow us to very quickly create plots from them. So all I have to do to plot the data in this data frame is just call the plot function on it. And there I get a plot. Now this is not a great plot because the units are different. Of course, oil is in barrels and gas is in MCF, but we could quickly, I'll just show you how you could go ahead and kind of make this plot a little nicer by using the matplotlib plotting language. Matplotlib is the standard plotting language in Python. If you take our energy data science course, we covered it in quite a bit of detail. So we'll import matplotlib as PLT, and then we're going to create a set of axes. And we're going to twin or create a second set of axes so that I can plot the gas in its own unit system on a second axis that shares the x-axis with the initial one we create. So I'm just going to give it some labels, as well as just some styling. So in this case, I'll just reuse this code, changing axis 1 to axis 2 and gas in MCF. So again, all of that is just styling. Now we can grab just the oil column of our data frame, again, referring it to it by the label, plot it, passing in the axis we just created. And we can do the same thing for gas. Again, I'll reuse the code here. So pulling off only the gas column. We want to plot that on the second axis in the color red. So if we do that, we should get a nicer plot, right? So now these are months of production. We have oil on the left and gas on the right, and we've included some color styling. So nothing too complicated there, but just demonstrating how we can make our plots a little nicer quickly. So now we'll go ahead and begin to create the additional columns that we need to do our economics on this well. So the first thing we want to do is compute the ultimate recovery. And so the ultimate recovery is just the sum of the projection, right? Remember, so these type curves were fit to real production data up to some point and then projected into the future, okay? And so if we expect this well to be in operation or potentially be in operation for, 500 months, we can project it into the future that far. Let's see, I have another question here. You will have access to the notebook if you sign up for free access to the data management, the learning management system that Avi covered in the introduction. So again, I'm going to create a variable here that I'll call gas ultimate recovery, and it's just the sum of the gas column. And the way we do that is we refer to it using this type of syntax that gives us the gas column, and then we can just sum that column. And so then if we were to look at what this is, that's the total production over the ultimate recovery of gas over the entire time here. So we'll do the same thing for oil. And these are just temporary variables here that we'll use to add to our data frame shortly. So then if we want to have a column, again, as we did in the Excel notebook for % EUR gas, the way we add a new column to a data frame is just we just give it the label that we want and set that equal to whatever the computation is. So this is the right-hand side of this equal sign is your formula that you're used to inputting into Excel. However, in this case, I'm going to argue that these formulas are far more readable and testable. So again, I'm just going to take the total gas, divide it by the gas ultimate recovery and multiply by 100. And that's going to give me a new column in the data frame, right? So the left-hand side defines what I want the new column to be named. And the right-hand side is my formula. So I'm just dividing each month of gas by the ultimate recovery and multiplying by 100. And this is each month's percentage of the estimated ultimate recovery. We'll do the same thing for oil. And like this. So now we have our new data frame. Now, what we're going to do next involves a lot of equations from resource economics. So computing the monthly revenue for oil and gas, NGL, applying the taxes and other things. And these formulas aren't extremely complicated, but they are or can be far more complicated than what you really want to code in Excel or just due to, again, software engineering issues like testing and other things. And I'll give examples later where things get a lot more complicated. However, so what we're going to do for these, instead of just defining them on the right-hand side of equation as a formula, right, like we've done up here, what we're going to do is actually define functions. And I'll show you how we're going to do that, and then I'll talk about why we do it. Right? So if you're familiar with Python programming language, you know that you create a function with the def keyword, And so our function is going to be called compute oil revenue. And the inputs to the function are going to be a data frame and the dictionary of inputs. So remember, this is our price deck up here at the beginning. So we're going to pass in this pricing information as well as the data frame into this function to compute the oil revenue. I'm just going to add this convenience variable that I'll call oil and gas inputs, which is just the oil section of the dictionary, because we're only computing the oil revenue. So in other words, returning to the price deck dictionary, what I'm pulling off here is just this part, because this is really all we're interested in to compute the oil revenue. So from here, then we'll just return. I'm just coding up this first formula, right? So the price of oil plus the differential times the net revenue interest times the monthly oil production. So I'm just coding this up, and we would have the price of oil plus the differential times the net revenue interest we can use auto completion within our Jupyter notebook. So what I did there was all I did was type net and then I hit tab and it auto completed the revenue interest part for me. And then that is times the oil production. So this function, if you give it the data frame and a set of inputs, it will return this, okay? So the way we then apply this to a column of the data frame is we would use the so-called apply command. So we're going to take the data frame, apply the function compute oil revenue. It takes some additional arguments. So by default, the initial argument to the function data frame is what you put here. And if there are any additional arguments, and the additional arguments in this case are inputs, this goes into a tuple there. And we have to add the additional command of axis. So axis equal to 1. That means we want to apply this function. So we want to do this computation down the columns of the data frame. Okay. Looks like I have a typo. And there's the output, right? So this function, computing the oil revenue, has been applied down the columns using the oil price information in inputs and the actual oil production that we're estimating. And this gives this data in return. So we can add this as a column to the data frame then, just as we did before. And the column will be called oil revenue. And so then if we look at the data frame, we have this additional column out here, right, where we've done this computation. So in the interest of time, I have another formula that I would want to compute for gas and revenue and taxes and operating expenses. In the interest of time, I'm just going to copy those in here. Again, they're fairly straightforward formulas, and the code is nothing more than just coding up what you see here. Now, the reason that we want to write formulas like this, as opposed to writing very complicated formulas like that, like you really only have the kind of the only way you have to do it in Excel, is that these functions are easily testable. It's very easy to write a small function that, the function takes inputs and returns something. And so you can write actually automated testing that will execute and compute, with known inputs and known outputs it will report to you whether your code is working correctly or not. And this is a real reason that you want to always break up your code into small kind of testable functions like this for code quality purposes. So with that, I'm just going to copy and paste the rest of those formulas. So again, I have an additional function for computing the gas revenue, computing the NGL revenue, the taxes and the operating expenses. And then I can apply those in the same way and add them as new columns to the data frame. Like that. I got the error because I added new code here but didn't execute those functions. Now everything looks good. So if we take a look at the data frame at this point, we've added several new columns: oil revenue, gas revenue, NGL revenue, taxes, operating expenses. We can now go ahead and compute our cash flow. So the cash flow is the sum across the rows of the revenue columns. So the way we'll do that is we'll use the loc command. So the loc command is how you sub-index a data frame. So again, the cash flow is the sum from oil revenue through operating expenses. And so what we'll do is we'll use the loc function to grab, the colon represents all columns. And then with respect to rows, we're going to take from oil revenue to operating expenses. So if I just run that, you'll see what the sub-index data frame is, right? So I just took a portion of the data frame. You notice that the month data travels with it, right? So even though I just took oil through operating expenses, the month is implicit. That's how we refer to every row. It's the label of the row, okay? And so, so then in this case, if I want to just sum across the rows, all I have to do is say sum x is equal to 1 implies sum across the rows. And now I have a sum across all of the rows for each of those operating expenses. And what we'll do there is we'll add that as a new column that we'll call cash flow. And again, let's look at our data frame. So now we have a new column out here, cash flow. Of course, we're not interested in any negative cash flows, so we'll go ahead and get rid of those, right? We don't plan to be operating a well if it's in a negative cash flow. So what I can do is to find where the cash flow is negative, I can just do an array-wide Boolean operation. So if I take the cash flow column, right? So again, if we just look at the cash flow column, and then I do a Boolean operation. So I say where the cash flow is less than 0. If I execute that, it's just going to give me an array of falses and trues, right? So false where we have positive cash flow and true otherwise. And so from that, what I can do is I can use this true false array to index back into our data frame. So this will only give me the rows of the data frame where I have true. So starting in the 301st month, we have negative cash flows. And so for all of those, I can just simply set it equal to 0. And now if we look at the data frame, you'll see that for every month past that 301st month, I have zeros in the cash flow column there. Now, what I accidentally did here, this is why live coding can be instructive, because I made an unintentional mistake here, but it can show you what I did. So what I intended to do was only to zero out the cash flow column. However, I didn't specify, when I did this type of operation, it actually zeroed out every column in the data frame. And so what I actually want to go back and do is, again, use that loc command to choose only the values of the cash flow column only and to set to 0, okay? And I think what I'll have to do here is run all the cells in the notebook to get back to where we were. So I'm doing that real quickly. And so now you see I did the correct thing there. I have zeros out here in the cash flow column where they were negative, right? So, and with just this one line of code here was able to, filter the data, find the negative values and set them equal to 0. Okay. So we'll add another column for the cumulative cash flow. So our cumulative cash flow is equal to the cash flow cumulative sum minus our capital expenditure. And again, looking at the data frame, we just now have a final column out here on the end. All right. So, I guess we can add one more column to tell us if when the well is economic. So we can just simply have, so far all of our columns have been numeric, but we'll, in this case, add a column that's Boolean. So it's be a true or false. So basically, if the cash flow is positive, then we have an economic well, and you'll see that out here, right? So true means the well is economic, false means it's not. So this is kind of our final data frame, but if we were to go back and look at the Excel workbook, there was some styling attributes that we might want. Like for example, in the Excel workbook, we were using accounting stylings for the numbers. So negative numbers have parentheses around them, dollar signs, whatever. So we have to do that through code here. And what we're going to do, and I'm just going to, again, in the interest of time, I'm going to have to copy and paste some code here. So this first bit of code here creates what I'm going to call a format dictionary. And we can actually look at what that is after I run this. So it's just a dictionary that maps the column names, oil revenue, to functions. And these functions just apply styling to our data frame. So then if we go ahead and run this on our data frame, so now we have, we've applied this styling. So again, what these, the individual aspects of what this is a little bit beyond what we're doing here. But basically what this is doing is just adding styling, right? So it's rounding off the numbers to whole dollars. It's placing a dollar sign in front of it in the case of all numbers. And in the case of negative numbers, it's placing parentheses around it. So it's just applying the, again, accounting styling to the notebook. We can do some other things, which, this starts to get beyond what we can really do in Excel easily, that I think is pretty interesting. So for example, we can actually add a bar chart in the background of our plot, of our data frame. So what I'm going to do here, you see, I just call this on the end of the style command, I call this bar chart, where I have two colors, red and green. The minimum value is the minimum value of the cumulative cash flow. The maximum value is the maximum value of the cumulative cash flow. And I only want to apply this styling to the cumulative cash flow column. And I want the center, the alignment, the center of the column to be at 0. So if we run this, now you see I have some styling here added to this cumulative cash flow column, which kind of shows me how much in the red we start. And, eventually you break even at this point and the cash flow becomes positive after that. and you can see, watch it grow in that way. We can also, for example, highlight the economic column to tell us, visually, show us visually where our wells would become economic or not. So I'm just going to add this additional, in Python, you can, any really long command, if you just surround it in parentheses, you can split it into multiple lines. So we can see everything in one view here. I'm going to split this styling function up. Again, the first thing I did was the bar chart, and all of these commands are associated with the bar chart. And now I'm adding an additional styling, that is to highlight the economic column. If I execute that,
Hey, John, I don't think you're sharing your screen anymore.
sorry, I somehow lost my connection there. That's for that. Again.
Yeah, it looks like we're back.
Okay. I'm gonna stop my video to, I don't know if I had an unstable connection there or what, but I'm gonna stop my video. So you still see the screen, right?
We can still see the screen. It's blurry on my end. I don't know for everybody else. It's as blurry, but.
Okay. Looks like I still have a styling issue here. I'm not sure. It just has to do with these last commands. Because that should work. Okay, so the last thing I was trying to do there was highlight this column, trues and falses, but in the interest of time, I'm going to skip debugging that. But what we're hoping to see was, basically green and red there for true, when the well is economic and not. So the last thing we're going to do to kind of is create that so-called summary table that I was showing you. And to do that, we have to use the MPV and IRR computations. Well, nevertheless, we don't actually need this code anymore, so I'm going to move on. For that, I actually have to write those functions myself, and those require us to use some root solving functions from SciPy. And so in this case, we're going to compute the MPV given the rate, the data frame, and our inputs again, and we're going to compute the IRR again given a data frame and a set of inputs. And so from that, those functions we can create, in this case, a new Python dictionary. The name of the Python dictionary will be called summary, and it's going to have a keyword IRR %, where I'm calling this function applying it over the inputs in the data frame, as well as the MPV10, applying it over the inputs in the data frame. Additionally, we can quickly compute our rate of return. So again, these are just, I'm adding a new keyword value, right? So the keyword is return on investment in years, and the value is the result of this computation over here on the right. As well as last thing we had in that table was our summary. And so if we look at what this summary is, it's a dictionary, right? It's a Python dictionary as keyword, IRR, MPV10, return on investment, payout, and the values are just the numbers. Well, it turns out a Pandas data frame can easily be created from a Python dictionary by just, so we'll call this summary data frame, and we're going to use the Pandas data frame object constructor and then just feed it the Python dictionary. So now we've turned our regular Python dictionary into a data frame object. So we can just go ahead and do a few things here to clean this up. For example, we could round all the values. So we can round these values to 2 decimal places. We can also add some styling. So again, if we wanted to add like the, ensure that this is the same type of styling for the accounting style format. And then we're just going to hide the index because it's not meaningful here necessarily. So with that, we get this recovery, this summary data table. So from all this work, we have this, all of our resource economics calculations stored in this, and then we have this summary table. Now, from that, we had an Excel workbook that we started from. So from that, we've just recreated the workflow, but let's see how, what we can do to take it further. Well, one thing we can do is we can turn this workflow that we've developed in a Jupyter Notebook into an executable script. One of the easiest ways to do that is to simply go into your Jupyter Lab session here, go to File, Export Notebook as an executable script. And if you do that, it'll give you the option to download that to your desktop. And I've already done that for this file, for this particular workflow. So in this case, I've turned what was a Jupyter Notebook, IPyNB file, into a pure Python file. And let's go ahead and take a look at that real quick. So this is a pure Python file. And I've already taken the time to kind of rearrange the file. In other words, I put all of the functions at the top of the file. So XMPV, XIR, compute oil revenue, like all of those functions that we defined. And then everything else we did in creating that data frame, I put into a function called create full data frame. So in this case, it takes a single argument, that is the file name, the CSV file, the inputs, and whether you want to return the data frame or not. There's a question, can you make data frames from nested dictionaries? Yes, you can, but they would all have to have the same level of nesting, and you would use something called a multi-index to do that. And it's a little more complicated than what I showed here. We can talk about that in the longer course when we have more time. So I've taken this workflow that we created in our Jupyter Notebook, and I've converted it into a Python script that's executable. And so the benefit of doing that is now, and what I'll do is I'll return to our notebook and I'll show that we can now import. So we can say from type curve monthly, import one of those function names, and one of the function names was create full data frame. So now I have a function called create full data frame that sort of does everything for me all in one step. So if I call that function, I have to give it the file path again, data type curve 1.csv, as well as the inputs, and then whether we want it to return the data frame or not. In this case, I'll say true. And so now we can run this, and it returns all of the information that we want, right? So everything has been computed in one shot, running in that Python script, okay? So that was just testing that. But what we can do with that then is we can take it a step further. And again, we're getting close to on our time here, so I'm just going to copy the code in and show you what the results we have here. So there's some interactive features in Jupyter Notebooks that are available through this so-called IPyWidgets package. And if we run that, you can see my true false highlighting in the last column is now working properly. So that because I copied the code, it had already been debugged. But nevertheless, what we can do here is now we can play what if games interactively. So all I did here was I created another function called interactive data frame, which takes as an input oil price and operating expenses, adds those into our larger input price deck, and then calls that function create full data frame to produce this data frame output. And then, so what we can do with that is we can actually interactively see how things change. If oil prices go down, if they go up, how does that change our resource economics? Same for, if we can lower our operating expenses to some extent, how would that change our resource economics? The last kind of example here that's along these same lines is just to show you, if you really like one thing that people really like about Excel is the ability to, type in fixed values. Turns out you could actually do the same thing here. I can type in fixed values. So, if I wanted to see what the oil price was at, or what economics were at $50.31, I can simply type it in, as well as using the slider bar here to make those changes. But I can also have full explicit control over the widgets. So in this case, the default is just to select these slider bars. But I could also choose have another choice here. So in this case, I explicitly set the widget to be a text box, right? So again, a lot of people like the kind of data entry part of Excel, okay? And so the same thing here. The last thing I wanted to say was just that the purpose of creating an executable script like this is now as I can, it doesn't matter if I have the type curve economics for 1 well or 100 wells or 1,000 wells. I can run them just as easily. So for example, I have this into this executable script. I've written a little bit of code. And again, if you take the longer class, we go over all this in detail. But basically what that does is it loops over many type curves. I have 10 in this example, and produces that summary chart in an HTML format that's viewable to everyone. So for example, if I were to open up a terminal window, navigate to the folder where we've been doing this work, and then just simply run that type curve monthly as from the command line as a Python file. It's currently running right now. If you look over here in the file browser, sorry, I think I ran that in the solutions branch, but if you look over here in the file browser, you should see this summary HTML right here. And if I open that, now I have this summary chart for every, so in this case, I had 10 wells, and I created this summary chart, the same one, calling the same function that we wrote. But now, I could have this run automatically every day, and I could look at, how the things are changing. I could have it pull from an API, getting the most active, recent pricing information. Have this run automatically every morning, and even have it say, send me an email, so that, when I come into my office every morning, I just open the email and I look at what the economics are for the wells that, I'm in charge of. The last thing that I'll talk about in the remaining, 3 or 4 minutes here is that, in this case, we took the the type curve information as it was given to us, as if it was an input or fixed. But we could also create our own type curves. I mean, we have the full power of Python available to us, so we could create our own Python, our own type curves as well. So if I just scroll down to the bottom here to open up a new cell, we'll just look at how we might do that real quickly. So we actually, we have a database of production data available to us in our learning management system. It uses something called intake to pull that in. So I'm gonna do an intake import our catalog. And then I'm gonna get a well by its API number, the active production data. So this is again pulling from a live database. So here's a well I have the API number for. If I pull that in, it automatically imported that into a data frame. You can see this well, I guess, was shut in sometime in 2019. But what I can do, if you would like to look at this real quick, I can set the index to be the date, and then I can call plot on this, and we should be able to see let's see what, oh, I missed a set of parentheses here. So there's our production data. One thing I noticed right away is that there's a dropout for whatever reason. So there's some month here that's missing data. This is very common, and it's one thing that Pandas is really good at, is to come up with ways to handle missing data. And in this case, since we just have a missing month there, what I'm going to do is just interpolate between them. So I'm going to say that I'm going to input a value for that month that's missing, and it's going to be the average of the value above it and below it. I'll do that with this code here. So I'm just grabbing the months and grabbing the oil, that is the volume of oil formation barrels, using an interpolation method of order 1, that means linear, draw a straight line between that point and that point. And when I do that, then I have an oil data now that's not missing any values, right? So you don't see any nans or anything in here that were in our original data frame. We can see that if we look at that. It's oil formation barrels. Sorry, volume oil formation barrels. I guess we can't see it. Let's look at to array, to numpy. Yeah, so there was a missing value here in our original data, and it's been replaced with an interpolated value. So now we don't have any more missing data. And with that, we can then define a function. Our function will be the ARPS type curve model. So that is what I'm defining here as a Python Lambda function, and it's a function called model. And then we'll use the SciPy optimized curve fit to fit that model to our months and oil data. And we have some bounds that we're also placing on the parameters. For example, we know that the B parameter in the ARPS is generally between 0 and 1. So we've fixed those bounds. So this is, we've actually just fit a type curve to that. These are the parameters of that curve. So then we can then, if we'd like, create a new data frame using those parameters that we just fit. So if we look at that data frame, now we have the actual production and we have our modeled production, the ARPS model there. And if you want to see what it looks like in a plot, you can do that like so. So again, there's original data, and now we fit a model to it. And so if returning to our big resource economics workflow, again, we used production data, we used type curve information as an input, or as something we started with when we ran this analysis. However, there's no reason that we couldn't build the very type curve analysis right into our script so that every morning we have new production data, we can fit a curve to it, do all of the economics, have it run automatically every day, and have everything coded up in a way that can be automated, is reproducible, with continuous integration, unit testing, so you have high quality workflows that you can trust. Again, we talk about all of that in the micro course, Pandas for Excel Addicts. If you register today, there is a 10% discount, and that discount code is Pandas10. So with that, in the last minute, I'd be happy to answer any questions. And if there are no questions, thank you for joining us.
John, there's some questions in the chat window as well. Hey, John, there's some questions in the
so
chat
I'm
window.
looking at it.
Oh, sorry.
Yeah. So I don't understand the question. Is it not Excel? Helen, do you want to elaborate on that? And in the meantime, I'll answer the other question. Sir, is there any idea how to run sensitivity by plotting them on a spider diagram? There are several ways that I could come to mind to that. I mean, for one, you could just use if you have information about the error bars and the inputs, you could run them through the data frame and it would produce error bars in the outputs. I mean, you could run them through the entire calculation and have error bars in the outputs. So it would give you some idea of the sensitivity of the inputs to the outputs. I don't know if that's what you're saying there. If Helen's still with us, and I don't understand the question, is it not Excel? But be happy to answer any more questions. Okay, well, I guess we'll end this webinar. Thank you for your time. Please join us for one of our other courses, or if you'd like to learn more, join us for the micro course, 2 half days, Pandas for Excel Addicts.
Thanks, John. Thank you, everybody.